Four matrices A, B, C, and D are shown below. Now, it might be worth just taking a moment to write down the size of each matrix. So this one's got 2 rows and 3 columns, so it's a 2 by 3. This one is a 3 by 1. This is a 3 by 3. And this one is a 1 by 2. So the square matrix, remember, that's when you've got the same number of rows and columns. That one is the 3 by 3 matrix. Calculate 2c plus 5i, where I is the 3 by 3 identity matrix. So we want twice matrix C. So now C is 1, 0, 5, negative 1, 2, 0, 4, 3, negative 2. And then we want 5 times the identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. Remember, identity matrices always have 1s on the leading diagonal and 0s everywhere else. So that's going to be, we just multiply every element in here by 2. So it will be 2, 0, 10, negative 2, 4, 0, 8, 6, negative 4. And then every element in here is multiplied by 5. So that is going to be 5, 0, 0, 0, 5, 0, 0, 0, 5. And so we're going to have 2 plus 5, which is 7. Then 0 plus 0 is 0. 10 plus 0 is 10. And then we'll have negative 2 add 0, which is negative 2. 4 and 5 is 9. 0 and 0 is 0. 8 and 0 is 8. 6 and 0 is 6. And negative 4 add 5 is 1. And then the next thing is calculate D times A. It's worth just taking a moment to say that D is a 1 by 2. A is a 2 by 3. And so we can do the multiplication, and the product matrix is going to be a 1 by 3. So we've got 5, 2. So I should use square brackets. And then we've got A, which is 0, 2, 4, negative 3, 1, negative 2. And we discussed that that would give us a 1 by 3, just so a single row with 3 columns in it. So we need to start with the 5, 2 being multiplied by 0, negative 3. And we do this by turning the 5, 2 sideways, so it goes in this way round. So we do the 5 multiplied by the 0, which is 0, and the 2 multiplied by the negative 3, which is negative 6. 0 add negative 6 is negative 6. We then do the same thing in here. So the 5 and the 2 come in and multiply here. So 5 times 2 is 10. 2 times 1 is 2. Add those together, you get 12. And then the 5 and the 2 come in here. And we do 5 times 4 is 20. 2 times negative 2 is negative 4. 20 add negative 4 is 16. So we get negative 6, 12, 16. Determine the values of P and Q given that P times negative 2Q3 is equal to B. So what we've got is P times negative 2Q3 is equal to the matrix B. And the matrix B was 8, 0, negative 12. So negative 12. Now we can see from the top and the bottom that P must be equal to negative 4. So negative 2 times negative 4 would give us positive 8, and 3 times negative 4 would give us negative 12. And then from the middle, we've just got P, Q equals 0. Well, we know that Q is negative 4. P is negative 4. So negative 4 times Q is 0. And the only way that can happen is if Q is equal to 0. So P is negative 4, Q is 0. So finally, if E is equal to A times C, determine the value of E21. So let's just think about A and C again. So A is 2 times 3, and C was our square matrix. So 3 times 3, middle numbers are the same. Product matrix would be 2 times 3. Now let's just think about doing A times C. So what is the matrix A again? So A was 0, 2, 4 in the top, and it was negative 3, 1, negative 2 in the bottom. Let me just check that. Negative 3, 1, negative 2. C has 1, 0, 5 in the top. It then has negative 1, 2, 0. And finally, 4, 3, negative 2. Now that's going to give us a 2 by 3 matrix. So the elements will be here, 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 here. And E21 means it's in the second row and the first column. So to get that one, which is in the bottom left of our product matrix, we need to be doing the bottom times the left in the original matrix. Remember, we turn the negative 3, 1, negative 2 sideways, and then we have 1, negative 1, and 4. So that gives us negative 3, because we're multiplying all of these, negative 1, and negative 8. And then we need to add those up, which gives us negative 12. So the value there, which is E21, is going to be negative 12.